Welcome to Biochemistry 412, the Biochemistry Lab. We will have a hands-on approach to your biochemistry classes, such as 410 and 411. This class is offered in the fall and summer 2 semesters, but it's not offered in the spring semester. I'm your lab instructor, Dr. Ayers. My office is in room 210 of biochemistry. You will also see me in the laboratory. My email address is posted there. It's also, along with my office hours, posted on the Canvas website, as well as the TA's office hours and contact information. You may also make an appointment with either the TAs or myself outside of office hours, but you can also go to any TA. So if your own TA has hours that you can't make, you can try a different TA too. The TA information is, like I said, posted on Canvas. Our administrative associate is Mrs. Tilly Rausch. Her email is trausch@tamu.edu. If you have an excused absence or if you've been sick, give her your absence note within 48 hours per university rules, and she will arrange a makeup lab. Note that makeup labs are same week only. In this class, we'll cover the theory and principles of electrophoresis, chromatography, biochemical assays of different types, biochemical calculations. Biochemistry has a lot of math in it. We'll help you with this. We'll also spend a fair bit of time analyzing and interpreting our experimental data. What does it mean? Have you done the experiment successfully? We'll also cover the use of some common lab equipment and how to keep a lab notebook. What you need for this class is the lab manual, which is called Course Notes, at the bookstore, on Canvas, or at Textbook Solutions. The Canvas modules also have the relevant lab manual sections for each day. However, you need the physical copy of the lab manual to work in the lab. You'll also need a bound lab composition notebook with lines, not graph paper, no spiral notebooks. They make it hard to read. And we don't want to be able to hide any of our data, so that's why not spiral. And a calculator. Simple calculator can work. Fancy calculator is fine too. Generally, you can't use your phone calculator on an exam or on a quiz, but a simple calculator works, and I do have some spares in the lab. There's the breakdown for the grades. Note that the worksheets, most students will get all A's on the worksheets. We're happy to help you with them. If you don't understand, if you don't get the worksheets done correctly, you're not understanding the material. So make sure you work together or come to us for help. The real distinguisher for grades will be the quizzes and your final exam. So don't feel like you're doing super well if you've got all A's on the worksheets, because pretty much everybody does. There are also some points for lab performance, which we'll talk about in a bit. Do you see any discrepancies in the grades that are posted? If we post 29 instead of 92, come to us within a week and we'll fix it. I don't want to see changes after 1 week, because otherwise you'll try to show up in my lab, in my office, the end of the semester to get 5 more points on this worksheet or 2 more points on this quiz, trying to get up a letter grade. So make any changes within 1 week. Your lab performance grade, well, in the class, most of our work is done in pairs. However, I expect that both partners will participate fully. If one partner does all the work, you will be graded accordingly. If you already work in a research lab and you're terrific at pipetting, make sure that your lab partner also knows how to pipette. Or if you send them back to make a new cuvette at the spec, and they can't make it, it's going to hurt both of you. If you are a safety hazard or if you ignore lab rules, your grade will reflect this, particularly now with COVID. Make sure that you're not a safety hazard. All work should be done in your own words. You can work in pairs or in groups, but you should answer the questions independently. Graphs and charts should be in your own words. Any identical or very similar answers will get half credit. For your lab notebook, It's a record of what you did and why. It's very important to be able to repeat experiments. You should be analytical about what you put in, reduce it to critical information, not everything. The lab manual covers in great detail all the experiments that we're doing. Much of what's in there, once you've done it once, you don't need to write down how to do it because it'll be obvious once you've done it. For making an SDS gel, I don't expect you to open the petals, close the petals, slide the gel in. The next time you do it, you should be able to remember it. So don't waste your time writing everything. Just put the critical information. It needs to be clear enough to repeat later or by somebody else. Sometimes, not infrequently in a lab, you have to go back to an experiment you did 2 or 3 years ago, or to a lab notebook that somebody else did the experiment a few years ago. You have to repeat it. If you don't have enough information, you may have to spend a lot of valuable time trying to figure out how the notebook was done. Many experiments are very complex and need notes. There's a famous case of a Dr. Ringer in the 1880s. He developed a Ringer's saline solution. His experiment, he was trying to figure out what it took to keep frog hearts beating when they've been dissected out of the frog. He tried solution after solution. He kept on going, killed lots and lots of frogs in London. And then one day, the frog heart kept beating. He was at first confused. He had done that kind of saline solution before and it had not worked. So he didn't know what was going on. Luckily, his technician took good notes and he realized that batch of chemicals had been made using river water straight out of the tap instead of purified water. And then he knew it was possible and he had to figure out what was in the river water. Even the TV shows of 20 years ago or something, you would all the time hear, give them Ringer's saline. It's a very famous solution. Sometimes your work might be important for patents. You might even use expensive notebooks where you have to have someone sign and date it every day to document when the work was done. For your notebook, you want to put your name on the cover, write legibly in blue or black ink, preferably on only one side of the paper, especially like Sharpie pens and things like that go through. And if you write on both sides, it's very difficult to read. Put a title page with your contact information and your TAs, etc. Also, be a good idea to get your lab partner's information. One semester in spring for my biochemistry majors class, I had a student who came into me. He had been dumpster diving. He was in the notebook studying for the final exam. He was in the library studying for the final exam. He lost his notebook. He thought they'd picked it up and put it in the dumpster, so he had literally been crawling in the dumpster looking for it. He did not find it. I did not doubt his story because when you dumpster dive in late April, you tend to be rather fragrant when he came into my office. Luckily for him, someone the next day called him and had found his notebook, so he got it back in time to use it for the final exam. Yes, you get to use your notebook, but not the lab manual for the quizzes and the final exam. So contact information can be important. It can be useful to have a table of contents, at least order the experiments. We don't typically use the notebooks that have page numbers. If you want to put page numbers on to find things more quickly, you go for it, but you don't have to. Before you come to class, read the lab manual and fill it out, handwritten in ink. I'll point out that we now have the lectures online and the videos for how to do the experiments. You need to watch all of this, read the lab manual, fill it out before you come in so you're prepared to work. You need to have the title and date of your experiment, the purpose, usually 1 or 2 sentences with the overall reason for the experiment. Today I'm making a cell-free extract to prepare it for using for protein purification. Background, 1 or 2 paragraphs on what and why you're doing it. Why are you doing this extract? What is in it? What proteins are you going to purify it? How were they made? Why are they in there? That kind of information. Also, procedure with enough detail to repeat the steps years later, even without the lab manual. You don't need the level of detail of the manual again. I don't care if you use lists, flowcharts, diagrams, etc. But I love troubleshooting questions on the quizzes and on the final exam. And if I ask you, what happens if you do your experiment by centrifuging at 80 RPM for 10 minutes, and you normally centrifuge at 8,000 RPMs for 10 minutes, but you did not write that down, it is harder to figure out what would go wrong. For your results and data analysis, things that are done during class and others that are done after class, you should include your raw data, tables, calculations, especially if you're not comfortable with the calculations. Put some samples in there. There's a calculation help section at the front of the lab manual and in the website too. Any graphs, if you do a graph in Excel, we'll be doing a bunch of graphs in Excel or Google Docs. I don't care what you use. You can simply print that and glue it into your notebook. Pictures of your gel, you're going to take an image of your SDS page. You can glue that into your notebook and label it. Everything else should be handwritten. Sometimes though, there's no real results. You simply, maybe you can write down how you labeled your samples. If you come back to these samples 2 weeks later and you've written it down or your lab partner had, if you don't know what is in there, it can be hard to figure out how to proceed. For discussion, put what your data means, what went wrong, if anything. And then conclusion, something that is supported by the data. I successfully purified GFP and RFP TAP. I did not successfully purify GFP and RFP TAP, possibly because, and give some reasons. For your lab notebook, you cannot have any loose pages. You can't glue in any manual pages. You can, however, include calculations, data, etc. Note that much of this is done on the worksheets. If I give you a worksheet that takes you through all the steps to calculate specificity constant, if you think you know all of those steps without having them in your notebook, fine, you don't have to put them in. But perhaps it would be wise to put them in so you can repeat it if and when I ask you on the final exam to calculate a specificity constant. Also, put in any information about what you did and why. Why are you separating GFP and RFP TAP? What is GFP? What is RFP TAP? You can add a notes section in the back of the notebook. You're also welcome to make notes as you go along in the appropriate pages of your pre-lab, whatever works for you. Note that again, the quizzes and the final exam are open notebook, but not open lab manual.